Right, welcome back. It's Miss Stover again. We're going to be talking about ion formation for those of you that didn't quite get it in class. Right now we're just going to review really quickly dot structure and see if we can come up with a better way or, make sure that we understand dot structure a little bit better. So here we go. Arsenic. Arsenic's dot structure is going to be AS, and it's going to have 5 dots because it has 5 valence electrons. Astatine is going to be AT, and it's going to have 7 dots. Potassium, pretty easy, K, and it has 1. Silicon has 4 dots. Thallium, TL, is going to have 3 dots. Oxygen is going to have 6 dots because it has 6 valence electrons. Lithium is going to have 1 dot, and krypton, a noble gas, is going to have 8 dots. So that should be a review of dot structure. The next slide is also going to kind of review dot structure for you. These are all the dot structures that you should have on your lab that you did. So I would make sure I double check to make sure that I had the right idea here. You can see that here we have 1 valence electron with 1 dot, 2 valence electrons with 2 dots, 3 valence electrons with 3 dots, 4 valence electrons with 4 dots, 5 valence electrons with 5 dots, 6 valence electrons with 6 dots, 7 valence electrons with 7 dots, and finally over here we have 8 valence electrons except for helium. And when we say 8, we usually say it's got an octet of valence electrons. Now helium has what we call a duet. It's a duet because there are 2, octet because there are 8. Helium is the only element on the periodic table that is stable with 2 electrons, and all the electrons that are close to helium, like lithium and beryllium and boron, are going to want to do what helium does. But we're going to get to that next. So ions. What makes an ion? Basically, what makes an ion is exactly what we've been talking about. Ions are formed because elements want to be stable. How do we know things are stable? We know things are stable because they have full valence shells. So this whole idea of an octet and a duet makes us understand that. So when we look at valence and we see that there's 1 valence electron here and 2 there and 3 for all this group and 4 for all of this group, I'm sorry, I don't know why it's doing that. 4, 5, 6, 7, and officially these are 8. We know helium's the exception. So we're going to be using that information to help us decide what all of the other elements other than this group right here, the noble gases, is going to do, because they're not going to form an ion ever. They do not want to lose or gain electrons at all. And so this whole idea of forming an ion is all about how many electrons would an element lose or gain in order to become like a noble gas. And it wants a cost that is within the realm of possibility for it. So the lowest cost, basically. So if we look at lithium, here we are. Here is lithium. Lithium, we know, has 1 valence electron. So it can lose 1 valence electron and become like helium, or it can gain 1, 2, 3, 4, 5, 6, 7. So the cost of becoming like neon is 700 energy bucks. The cost of becoming like helium is 100 energy bucks. Well, lithium is going to spend the 100 energy bucks to become stable. Both are stable, but the cheaper cost is better for lithium. So lithium is losing a negatively charged particle. So lithium will become a positive charge. So it becomes Li plus 1. Now what's really happening in the atom is this. Lithium as an atom has 3 protons and it has 3 electrons for a total of no charge. But now as an ion, what lithium is doing, it's still going to have 3 protons. It can't change the nucleus. But now it's lost an electron. So now I'm 1 electron short. So when I add that together, I have a total charge of plus 1. And you'll see that this plus 1 is the same as this. I just use this to kind of help you remember that I'm minusing a minus charge. So a minus in math means a plus charge. So lithium would form this ion right here, a +1. So let's look at the next guy, beryllium. Here we go. Beryllium is right here. Beryllium has a valence of 2. So that means it could lose 2 to become like helium for a cost of 200 energy bucks. Or it can gain 1, 2, 3, 4, 5, 6 for a cost of 600 energy bucks. So which choice does beryllium make? Beryllium makes the one that is the least expensive for it. The least expensive would be to lose 2. So it's going to lose 2 minus charges. That means beryllium is going to end up with a +2 charge. So beryllium, Be, is going to be +2. Now again, as an atom, beryllium has 4 protons and 4 electrons for a 0 charge. But as an ion, beryllium has still 4 protons, but now it only has 2 electrons for an overall charge of +2. So this is what's happening in the atom, the difference between an atom and an ion. But this is the overall outcome that we're looking at, this Be +2. So the next one here, next one is boron. Here's boron right here. Boron is right here. It has a valence of 3. It can lose those 3 electrons and become like helium for a cost of 300 energy bucks. Or it can gain 1, 2, 3, 4, 5 electrons for a cost of 500 energy bucks. Well, I think we know the deal now. I think we're kind of getting it, that the smaller cost is going to be the one that it wants to take. So we're going to minus 3 minus charges, which means we're going to have a +3 charge. So boron would take a +3 charge. Now, if boron, we're looking at atoms and ions here. Okay, boron has 5 protons and 5 electrons for a 0 charge. We know that from our previous discussions. Boron is still going to have 5 protons as an ion, but now it has 2 electrons instead of 5 for a +3 charge. Okay, so this is boron's ion configuration. So next is carbon. Carbon is a funny guy because carbon is our halfway point. That means carbon can lose 1, 2, 3, 4 for a cost of 400 energy bucks to become like helium, or it could gain 1, 2, 3, 4 for a cost of 400 energy bucks to be like neon. Now, this is the deal though. Carbon is a little funny because this family officially is said to be plus or minus 4 because they have a choice. It's hard to figure out what to make of that choice. So we either have 2 situations for ions here. We have carbon with 6 protons and 2 electrons for a +4 charge, or we have carbon with 6 protons and 10 electrons, oops, sorry, that should be a minus charge, for a -4 charge. So it's a halfway point, and we'll talk more about that one later. Next guy, nitrogen. Here we go. Nitrogen is right here. So nitrogen has 2 choices. Remember, they all have choices. So he can lose 1, 2, 3, 4, 5 to become like helium for a cost of 500 energy bucks. Or he can gain 1, 2, 3 for a cost of 300 energy bucks. Well, we can see this is a lower cost than the 500. So that means we're going to add 3 electrons. Well, adding a negative means a negative. So nitrogen is going to be -3 charged. If we look at that in terms of atoms and ions, same kind of idea. Nitrogen has 7 protons and normally would have 7 electrons for 0 charge. Well, it still has 7 protons, but now it gained 3 electrons. So now I have 10 electrons for a total charge of -3. So you're starting to see that there's some sort of a pattern here. Oxygen, here we go. We have oxygen. Oxygen has choices again. There's oxygen right there, valence number of 6. It can lose 1, 2, 3, 4, 5, 6 for a cost of 600 energy bucks to become like helium, or it can gain 1, 2 for a cost of 200 energy bucks to be like neon. And I think you're finally figuring it out, that we're adding a -2. So that's going to be a -2 charge. So we're going to have oxygen -2. And we can see that oxygen would have 8 protons. It would have 8 electrons for a 0 charge as an atom. It would have 8 protons as an ion. But now it has 10 electrons. So it has a -2 charge. So we go to fluorine. Fluorine again. Here's fluorine, valence of 7. I think we already know it's going to lose 1 for a cost of 100. Otherwise, it would have to gain 7, or no, I'm sorry, lose 7 or gain 1. Lose 7 to become like helium or gain 1 to become like fluorine. So we're adding 1 charge, which means a -1. So fluorine is going to be a -1 charge. Okay? So I think that you're starting to get this idea of ions. So neon, is neon going to form an ion? And the answer is no. Neon is already a noble gas, so neon will never have a charge. It will just always be neon. It's already stable because it's already full. It has no need to lose or gain. Okay? So now I want you to try these and tell me what ions are formed from these particular atoms, and we'll be referring to these a little bit later.